Okay, so now we're going to look at applications of inequalities and absolute value. Where do those apply in the real world? All right. Can create absolute value inequalities to represent real world situations and understand reasonable solution sets. Solution sets are things that make statements true. So, what are the numbers that make this a true statement? So, first one is the number of music cassettes C sold in each year is decreasing and can be approximated by this equation, where T is the number of years after 1995, and we'll talk about that in a second. There is enough shelf space in music stores for cassettes as long as the number does not exceed 150 million. So there's some key points in that word problem. So when we talk about inequalities in the real world, we're talking about phrases as at most, at least, cannot exceed, maximum, minimum, all right, those kind of word problems. So write an inequality that models this condition. Well, we are comparing to 150 million the total number of cassettes that we have, but this total number of cassettes that we have cannot exceed 150 million. So it's got to be that, where 150 is our biggest number. All right, we'll talk about that in a second. On the other hand, the number of single compact disc CDs sold each year is increasing and can be approximated by this equation. If the number of single compact discs can be produced as at most 100 million. So once again, that's an upper bound. That's a upper limit. That's a maximum. At most, it's 100 million. So we got 100 million as our number we're comparing it to. The number of cassettes sold has got to be at most that. So it's on the other side of that inequality. We can equal it, but we can't exceed it. Now C is just describing both of these, or solving for both. Now, to save us some time here, I'm going to solve it. All right. So we know we subtract, divide, all those things. We divide by negative, you flip-flop the sign. So here we get 3.7 is less than or equal to T when we solve. And over here we get T is greater than, I'm sorry. We get here that 5, or T is less than or equal to 5.2. So now we have our lower bound and our upper bound. T is greater than or equal to 3.7, but is also less than or equal to 5.2. Now, one thing we got to remember. T was in relationship to 1995. So T was years after 1995. So that means this would translate to 1998, and this would translate to 2000. In fact, it'd be 2001 because it's greater than 5. But don't worry too much about that. And plus, this is a problem we discussed already. So those are your inequalities. All right, at most, at least, maximum, minimums. All right, cannot exceed, has to be above. All right, now the next one deals with our absolute value. These are our tolerance problems. These are our within problems. You know, if I make a bolt at crown, hey, that bolt needs to be 5 inches. How often is it exactly 5 inches? Almost never. All right, it's 5.0001 or 4.997. All right, but as long as it's within these ranges, we are good to go. It's a good product. If not, it's a defective product. So when surveys or polls are taken, the margin of error is usually stated. For example, this worldwide poll indicated that 62% of Americans picked out letdown in moral values as one of the major causes of today's problems. Well, the margin of error is plus or minus 4 points. Now, what they usually do with polls is they'll take the same poll all across the nation. Well, is the same poll going to produce the same numbers if I'm going across the nation? I mean, if I ask that question to Mercer County and I ask that question to Franklin County, which is Columbus, are those going to be the same answer? No. So what they do to get that 62% is they take this poll, go across the nation, take all the results, and then they average them. Then what they say, the plus or minus 4 percentage points of the margin of error is no matter where you go, most of the time it's still going to fit within that. So 62 might be the average. In Mercer County, we might answer more like 59%. Maybe in Franklin County or Columbus, they answer more like 65%. But it's going to be within that range for the most part. All right. Now, before we actually write this out, I do want to write this down. This is how any kind of tolerance within, all right, absolute value problems. We'll have an actual measurement. So our actual amount, and I put this is the variable. This is where we're going to have X, and we're going to have whatever we have to represent the variable, minus the predicted amount. That is what's within our absolute value. Now that predicted amount is going to be the number. All right, whatever number we're comparing it to, what it should be. All right, maybe think of it that way. And then it's got to be within some kind of error. Words there would be variance tolerance within. You know, maybe up here you think of this as within 4 points. So now we will take this and we will make it situational to this problem. So write an inequality that represents the percentage of people. So P is our percentage. That's our variable. So the percent minus what it should be, which is 62%, it's got to be within 4 points. Well, real quick, let's think about what that should be. If 62 is what it should be, but I know I have this tolerance of 4 points, plus or minus. If 62 what it should be, what's our top end? Right? And what's our lower end? Right? That's what it should be, right? There's your actual range. Now, let's go back and I'll show it with math. What's inside? Could be the positive of that number. What's inside could be the negative of that number. So we add 62. This is where we get our 66. We add 62. Remember, it's not the opposite of 66. 62 minus 4 is 58. That's where we get our range. So 62% should be our national average. All right, that's what it should be. You go do random polls around the country, what it's actually going to be is probably between that range, 58 and 66. All right? You know, if you listen to a good poll, they should have a margin of error because it's never going to be perfect. Hey, let's say we're at a bolt, right? I'm at crown. All right? I'm trying to make a bolt. So my bolt should be 5 inches. Well, I'm going to take away what it was, -5, to get how much it's off. This has to be within 5/1000ths of an inch. Well, I do all this work. Here's my range. All right? Not every bolt's going to be perfect. As long as it's between that range, hey, you're good to go. Does anybody know what the average body temperature should be? 98.6, right? So here's what your body temperature is minus what it should be. Oh, let's see. I think they give you like a 5-degree difference. Meaning if you add 5, holy crap, I'm going to be really hot. But is our body temperature always higher? It could be lower, right? Hyper. Does anybody know the opposite medical term beside hyper? Hypo, there we go, right? So hypo is when it cools down, all right? So think about, you know, you getting stuck in ice cold water. Has anybody ever been in cold water? How's it feel? Oh, it's like 1,000 knives in your skin, ain't it? Polar plunge. I do it every year. Anybody wants to do it? It is not bad when you're here. When you dunk yourself, which I throw the grenade every year, when you dunk yourself, that's when it's, oh my God. Thank God they have the fried buffet after. Warm my butt up real quick. But this is all tolerance. Feel like we understand? So remember, your tolerance is outside that absolute value sign. That's how we get the positive and negative of that. All right. Hey, pretty much the same here. We're just going to kind of do this. Try to follow a formula. So we got to take our average of our lower and upper ranges. So that's how we're finding this red X. And if you think of it, it's going to be lower plus upper divided by 2. That's going to be what our average is. Now, the next is we're going to find distance. The distance those ranges are from the average. Now we got to think, and we got to be careful, the distance number should always be what? Positive, okay? And I'll show you in a second where, yes, I can understand you get a negative, but we just got to remember distance is positive. And then the only other thing we got to be careful of, if it's the absolute values on the less end, all right, it's on the smaller end of the inequality. This is within. If this is greater than the number, this is outside. So kind of what we were working on last week. So here it says the circumference of basketball for college women must be between this range. All right, we're going to come up with an absolute value inequality to come up with that range. All right, so we know not all basketballs are going to be perfectly the same. As long as they're within a ½ inch of that, we're good to go. So here would be our lower, here would be our upper range. So first is to find that lower plus upper divided by 2, which would be 28.5 plus 29 divided by 2. We'll go ahead, did the math for you. 28.7 is our average. Now the next is to find our distance. So we want to take the lower minus the average or the upper minus the average. Now if I take the upper minus the average, I get a positive 0.25. If I take the lower minus the average, I'll get that same root number, but the negative of that. Remember, we are dealing with distance, so we really only care. Doesn't matter if it's negative, we only really care about this number. All right? It's distance, we are thinking positive numbers. So for this particular problem, we want to be within. So X is the actual basketball that we're measuring. Hey, we keep that a variable because we're going to have different basketballs throughout the different course of the season. They're not always going to use the same exact basketball. Subtract out that average, which it should be average at 28.75. It's got to be within that tolerance of 0.25. So it's tolerant within a quarter of an inch. And that red is your final answer. That is the final. If we look here, this would be X minus X average within that distance. Okay, last thing to do today, try that same procedure, but with this problem. Here is your lower range. Here is our upper range. Now, your inequality will be based off of how these arrows are. Everything else is the same. So first find that average, the lower plus the upper divided by 2. Then find that distance between your average and the endpoints.